Enthalpy change. The amount of energy change per mole is called enthalpy change. The unit is kilojoule per mole. Delta H equal to heat change per mole. This is the mathematical definition. Here the Q is equal to mc del theta. Q is the heat change, m is the mass of the solution, C is specific heat capacity, and delta T is the temperature change. The types of enthalpy change. Exothermic. Here delta S is negative, heat is released. Endothermic. Delta S is positive, heat is gained. When hot water is taken in a beaker, it has the higher temperature than the surroundings, so heat releases to the surroundings. This is exothermic system. When cold water is taken in a beaker, it has the lower temperature than the surroundings. Heat is coming in. This is endothermic system. Exothermic chemical reactions, combustion reactions, methane plus oxygen, carbon dioxide plus water plus heat. Respiration reaction occurring in our body, that is exothermic. Neutralization reactions, acid plus alkali, salt, water plus heat. For strong acid, strong alkali, the enthalpy change is constant. Endothermic chemical reaction, decomposition reaction. When we are applying heat to calcium carbonate, calcium oxide plus carbon dioxide are produced. Photosynthesis reactions, carbon dioxide and water react. In presence of chlorophyll and heat, glucose plus oxygen are produced. This is endothermic system. Similarly, if we add ammonium salt to water, it will be cooler than the surroundings. This is endothermic. Bond breaking and bond making concept. Bond breaking energy less than bond making energy is exothermic. Bond breaking energy is greater than the bond making energy is endothermic. Calculate combustion of methane, the bond and breaking energy, bond making energy, and enthalpy change. The reaction is given, also given the data, bond energies. Before calculation, first I am to show the reactions showing all the bonds. Bond breaking energy. Carbon, hydrogen, 4 bonds. Each bond has 413 kilojoule per mole multiplied by 4. Oxygen double bond has 498 multiplied by 2, so total positive 2648 kilojoule per mole. Bond making energy. Carbon oxygen 2 double bonds. For each bond 799 multiplied by 2, and oxygen hydrogen, each bond has 463 multiplied by 4 oxygen hydrogen bonds. So the total amount of bond breaking energy negative 3450. Here the bond making energy is greater than the bond breaking energy, so here the exothermic, so delta is equal to negative 802 kilojoule per mole. Enthalpy profile diagrams. First, enthalpy profile diagram for exothermic reaction. Here the x-axis progress of reaction, y-axis energy. The reactants have higher energy than the products. The activation energy is shown. The activation energy is the minimum amount of energy to start a chemical reaction. The enthalpy change is negative. Energy profile diagram for endothermic system. The products have higher energy than the reactant. The activation energy is shown. The enthalpy change is positive. Energy profile diagram for exothermic system. In case of catalyst, in presence of catalyst, the activation energy is lowered. The broken line, it is shown. We need less amount of energy, so the reaction will be faster. Similarly, for endothermic reaction, the catalyzed system is shown. One example, hydrogen gas plus chlorine gas are reacted and make hydrogen chloride. This is exothermic. The enthalpy change is negative 184. We have to calculate the energy change. Here 2.5 gram of hydrogen and 142 gram of chlorine gas is added. First we have to find out the mole of hydrogen gas. Mass divided by mR is 1.25. Mole of chlorine is 2 mole. Chlorine has the greater mole, so chlorine is in excess and hydrogen is limiting, so we have to multiply the enthalpy change by the limiting mole, 1.25 multiplied by 184, so we are getting 230 kilojoule. Another example, methanol is manufactured from carbon dioxide and hydrogen. In this case 3 moles of hydrogen react and we get 49 kilojoule of heat. So we have to calculate how much energy will be released if 500 gram of hydrogen gas react. In this case, first we have to find out the mass of hydrogen in the gram, that is 500 kg multiplied by 1000, we get in gram, divided by mR of hydrogen, we get the mole. The data given for the 3 moles of hydrogen, we are getting 49 kilojoule of heat. So for 1 mole, 49 by 3, and for 250,000 will be multiplied. So we are getting total amount of heat release 4083333.3 kilojoule. Hydrogen fuel cell. Hydrogen derived from water or hydrocarbons. As a potential fuel for use in future, oxygen is collected from air by fractional distillation. Dilute sulfuric acid as an electrolyte. Graphite electrodes are used, which are porous. At the anode, hydrogen gas is coming and reacting and make 2 electrons. At the cathode side, oxygen gas and 2 hydrogen ions and electrons making water. The overall reaction is oxygen plus hydrogen, we get water plus energy. This way we can make energy from hydrogen fuel cell. Hydrogen fuel cell has some advantages and disadvantages. First, the advantages. Hydrogen fuel is renewable, environment friendly, rocket fuel, efficient fuel. There are some disadvantages of hydrogen fuel: expensive, highly flammable, difficult to store, not easy to replace existing infrastructure. Experiment to find out delta H. Ethanol is burned to heat water. Here the amount of water is taken 200 gram. Initial temperature, we just considering the amount, we are assuming 25 degrees centigrade, that is 298 Kelvin. We are assuming the final temperature 318 Kelvin, and temperature change is 20 Kelvin. So we know the heat change formula, Q is equal to mc del theta. M is the mass, C is 200 gram, and C is the specific heat capacity of water. This is the physical data 4.2, and the temperature change 20 Kelvin. So we are getting heat change 16,800 joule. If we convert it to kilojoule, 16.8 kilojoule. And the ethanol is burned, the initial mass of the spirit burner and the final mass, the difference is 2.3. We have to convert the 2.3 gram ethanol, we are assuming here, divided by mR, that is mole 0.05. We are dividing the heat change by the mole, we are getting the enthalpy change negative 336 kilojoule per mole. If you have any specific question about this topic, you can write in the comment below. I think you will get the correct answer. In this video, if you have learned anything, please subscribe this channel and share with your friends. Thank you for watching this video.